What's up, guys? Onmaths here, and today we're looking at simultaneous equations. Now, for this first question especially, there are loads and loads of different ways of doing it. I'm just going to do one of the methods. If you've got a different one that works, stick with it. That's absolutely fine. So I'm going to write out the equations just a bit bigger. Now, when it says solve simultaneous equations, what it means is find out what x is and find out what y is. Okay, so the first thing I do is I notice that I've kind of got to look downwards, and so with simultaneous equations you work downwards rather than across. Now I've got to get one of the coefficients, either x or y, the same coefficient, ignoring signs, so it can be plus or minus, but it's got to be the same number. Now I always focus on the y, and again you could have focused on the x, you'd still get the right answer. Or you could get the top equation so that it's y equals and then substitute it into the bottom one. There's loads of different ways of doing this. So I'm going to focus on the y. Now, the coefficient of the first equation is just 1 because it's plus y. The coefficient of the second equation is minus 3. So I'm going to times the top equation by 3. And we'll times everything by 3. So it becomes 15x plus 3y equals 63. Then I'm just going to copy the same second equation as well. There we go. So again, I'm looking downwards. Now, the next step is when the coefficients are the same, which they are, ignoring signs for this one, I look at whether the signs are the same or different. If they're the same signs, we subtract the equations going downwards. If they're different, we add. Simple as that. S same, S subtract, D different, and then the D in add. Simple as that. Now these are different, so we're going to add going downwards. So we're going to add those, then add those. Okay, so 15x plus x is 16x. Now this is the important bit. If I end up with 6y or minus 6y or anything like that, it means I've done it wrong. So let's have a think. 3y plus minus 3y. Well, the minus wins that one, so it's 3y minus 3y, which is 0, which is brilliant, because that's the whole point of doing the same subtract, add different, is to get rid of the y's. And then we've got 63 plus 9, which is what, 72. Get our lines in. And we had, what, divide 16 both sides. Now what we can do is just write this as a fraction, so it's 72 over 16, then simplify the fraction, so I can halve top bottom, so that would be what, 36 over 8, could do the same again, so that's 15, 16, 17, 18 over 4, do it again, 9 over 2, and 9 over 2 is what, 4.5, let's just extend my lines. Okay, so we know that x is 4.5, okay, and so we need to find out what y is. So we just go back to the original, one of the original equations, and so, I don't know, I'll pick this second one here, oops, I'll pick this second one here, and I'm just going to substitute the value in that I've just worked out. So instead of x, it's 4.5, minus 3y equals 9. Get my lines in. So I'm going to start off just by adding 3y both sides. Make it nice and positive. Then minusing 9 both sides. So 4.5 take away 9 will obviously be minus 4.5. And then divide by 3 both sides. 4.5 divided by 3 is what, 1.5, so it would be minus 1.5. So our y is minus 1.5 and our x is 4.5. Now if you've got time at the end of the exam, you could substitute those values into the equation we didn't use on the second one. So you could do 5 times 4.5 plus minus 1.5, but that does equal 21, so we know we've got it right. And as I said, there's loads of different ways of doing this. So if you do it a different way, if you make the x's the same, if you get it so it's y equals and substitute it into the other one, that's absolutely fine. As long as you get the right answer, stick with the method you're happy with. Okay, moving on to our AQA question. Now, with this question, we've got a quadratic and we've got a linear equation, and we're asked to find or to show that it only has one point of intersection, and we're told we can't use a graphical method. So when you have a point of intersection, it basically means a point where the x's and the y's of both equations are exactly the same. So if we've got this point where they're both exactly the same, it means the y's are exactly the same and the x's are exactly the same. Okay, so what we can do is we can just get these two equations and get them equal to each other, because we know that at this point the x's and the y's are the same. So I'm going to write in this equation into where it says y there. Okay, so we're going to have, you can do it either way around. I mean, you could put this equation into this equation where it says y there. Just get the two equations equal to each other. So 4x squared plus 5x plus 3. And because these are both equal y, what we're doing is replacing that y, but with this value here, or with this expression here, x plus 2. Then we get our lines in, and we just do a bit of rearranging, get everything on the same side, get it equal to 0, because then we can solve it. So we're going to take away x both sides. You could do this in one step really. So 4x squared plus 4x plus 3 equals 2, and then we're going to subtract that 2 both sides to get it equal to 0. You could have done that in one step. So we're looking to solve this. Now, I'd instantly think about using factorizing, but for us to only have one solution, it would mean that it would factorize in a certain way where both factors would be the same. So it would be like this. So it would be what, 2x and 2x, but these both have to be 1, and then these would both have to be add. So let's just check that. 2x times 2x is 4x squared. That works. 2x times 1 plus 1 times 2x is 4x, and 1 times 1 is 1. If you want some more information about how I did that, just look in our Factorizing Quadratics or our Quadratic Equation video, and that will show you how to do that. And then to solve it, we get both of these equal to 0. So let's get our lines in. Take away 1 both sides. 2x equals minus 1. Then divide by 2 both sides. And you get x equals minus half. And this is exactly the same. Now, do I need to do this again? No. Will I? Probably. Don't know why. It's pretty obvious it'll be the same because it's the same equation. So that's one way of doing it. The cleverer way of doing it is, and I'm going to put a box around this because we didn't need to do all this work. Okay. The other way of solving a quadratic, except for factorizing, is by using the quadratic formula. Okay, so the quadratic formula is x equals minus b plus minus the square root of b squared minus 4ac over 2a. Now this part here is known as the discriminant. And the reason it's got a special name is you can actually tell a lot about the amount of solutions by what that value is. Because we are plus and minusing that value, or the square root of that value, If it is a positive number, you get your two solutions always. If it's 0, well, when you add or minus 0, you just get the same number. So when it's 0, so when the discriminant, which is b squared minus 4ac, when that equals 0, you get one solution. Now, for those of you interested in understanding more about discriminant, if it's negative, you cannot square root a negative. Well, not with real numbers. You can't square root a negative, so there's no solution. So with this question, we're looking for it to equal 0. So we have a look at substituting in the b, the a, and the c. And I don't think we've done a video on quadratic equation yet. Maybe we have. But we will definitely do a video on quadratic equations, and the quadratic formula, I mean. So the a is the coefficient of the x squared, the b is the coefficient of the x, and the c is the number left over. So we're just going to substitute those in. So b is 4 squared minus 4 times a, which is 4, times c, which is 1. And when you do that, that's 16 take away 16. So that just equals 0. So the discriminant so one solution, and that might be a better way of answering the question because there's less working out. So, you can show it either way by actually working out the solution, but there's nowhere in the question does it say you have to show a solution. It just says show that it has one point of intersection. So either of those methods would work. Finally, our OCR question. Now, this is very similar to the previous question. We're given a linear equation and this time a circle equation, and we're asked to find not one intersection this time, but two intersections. And you can see them on the diagram. They are here and here. Now, if it was drawn to scale, we could just read them off. But quite clearly, the question says that this is not to scale, and there's no points on the graph. So we're going to have to do this algebraically, which is not a problem. So just as before, when the two lines touch each other, the x's and the y's are going to be exactly the same values. So what I can do is I can substitute one of the equations into the other. Now, it's easier to substitute the linear equation into the nonlinear equation. It is for me anyway. You could do it the other way around, but the problem is you'd have to rearrange this equation to make it y equals or x equals, whilst this one's already sitting there ready to go. So I'm going to write just the circle equation, but since we know that the x's and the y's of both the equations are exactly the same at the points of intersection, instead of writing y, I'm now going to rewrite it by writing 2x. So we've got x squared, but instead of writing y, I'm going to write 2x, and we've got to be careful here because it needs to be in brackets, because it's the whole of the 2x that's being squared. Okay, and that's all we need to be able to solve this. Because we're going to start by expanding the brackets. So 2 squared, which is 4, and then x squared, which is just x squared. Then put those together, be 5x squared. And then divide by 5 both sides. So we get x squared equals 6. And then square root both sides. Now there's a bit of a gotcha with this question. There's a word that it's going to be quite easy for us to not really pay attention to. It's this word here. When it says exact, it means do not round. And you might be asking, well, how do I not round when I work out root 6? Well, you just leave it as root 6. Simple as that. Okay, so what we're going to do is we're going to have a look. So we've already found one of the solutions, okay, and we can write that in our answer. So it's going to be root 6. But when you square root a number, you either get a positive or a negative version of that number. Okay, and the way of showing that is by just showing a positive version of root 6 and a negative version of root 6. Okay, and that's the way of showing that you've got a positive and a negative value. Okay, so we've now got to find out what y is when x is root 6. And we can just use this equation here. So it says y is 2 lots of x. Okay, and so when x is root 6, y is going to be 2 lots of root 6. Simple as that. So it'd be 2 root 6. And when x is negative root 6, y is going to be what? Minus 2 root 6. There's not been many times where I've not seen the question explicitly say leave your answer in third form and just use the word exact and expect you to kind of understand that you're not supposed to be rounding at all. This was on a calculator paper, so you could quite easily have written down the decimal, but I'm pretty sure you would lose some marks for not writing down the exact values. Well, I hope today's video has been useful. If it has, please click the like button. Please keep your comments coming in. We release videos every single weekday, Monday to Friday at 9 o'clock in the morning. So click subscribe and click the bell icon to make sure you're up to date with all the videos we release. If you haven't already, which I'm sure you have, check out our website onmaths.com, which is packed full of wonderful free resources to help you with your maths. There'll be a magic link that appears at the top of this video right now. Otherwise, thank you very much, and I will see you in the next video.